Okay. Oh, wow. Wow, 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 wow. That is significantly louder. Okay. Hopefully that's not, like, really terrible. Is this even using the right thing now? Okay, you should be able to hear me now. Can you hear me now? I'll check on my other monitor. Working now, perfect. I have no idea what it sounds like. I have no idea what happened. The audio device bugged out, and I had to disconnect and reconnect my audio interface. So I don't know. It's there now, though. Anyway, glad you're enjoying the videos and stuff. I was saying that we're going to do Mipmaps and texture compression today, and I can already tell that the first comment on this stream is going to be starts at 6 minutes and 30 seconds. So this is an example. Let's see. Let's go all the way back to... I've got a bunch of stuff here. This is a bunch of folders. All of these folders have been created in various ways. Where do I start? So maybe I run this. This should just run. Okay. This is currently a KTX file, but that's not enough to explain it. Okay, so I've got these new shell scripts here. And for a variety of reasons. So a couple months ago, somebody asked me to make a video on Mipmaps. I thought that was a really great idea. I started diving into Mipmaps and the suggestions for how to create them. I have a couple of those here already. That is cargo run bin, should be one manual Mipmaps. So there's a couple of Bevy examples in the Bevy example repo. This is a visualization of Mipmaps. So I actually have this in the VS Code, so let me show the VS Code. We have a bunch of different levels. Mipmaps are basically like, if you have a texture image that's 2048 by 2048, then based on certain heuristics, which we'll cover in a second, one of these images is going to get chosen. And they're all from whatever your original resolution is, half res, half res, half res, half res, half res. So in this case, all I've done is I've created a different solid color for each of the resolutions. So this is 2048. I know it's a little awkward because VS Code like resizes them for viewing. But this is 2048, this is 1024, 512, 256, 128. So the image on this plane is there's only one image on the plane. Yeah, I figured it would be too hot. Not much I can do about it at the moment, I think. I will fix it after stream. I saw it go really hot when I plugged it in. And I could probably do... What is this at? I could probably do this. Or this. One more. This. This might help, but it also might go a little low. I have actually no idea. And then... Yeah, how's this? Is this still crunchy? This is about the most I can do while I'm still on stream without listening to it back and checking. So this is one image applied to a plane that is rotating, right? That image contains a set of MIPs. What I did the first time was good, so I went good and then went back to crunchy, is what you're saying? Effectively, Mipmaps are the more texels you hit from a screen pixel, the further down the Mipmap chain you're going to want to go. I went good, then a bit too quiet. Okay. I'll bump it up one more. 39. I think that's it. That's about where it was. Okay, so again, one image applied to this plane. Based on it rotating, a MIP gets chosen. The whole image together with all the MIPs is all of these solid colors. This is a terrible explanation of MIP mapping while I'm also modifying my audio, but this is Mipmaps. And the way that the Mipmaps are displaying on this plane, they're being interpolated. So if we go to the third example has no filtering, or rather no interpolation between the MIPs. So you can see the MIP selection happens at specific points. This is a perspective projection camera, so you can see that kind of like perspective bending inside of the MIP choices. But that's it, right? And the code for doing this is not too bad, but nobody is going to do it this way in practice, right? So what I'm doing here is I'm taking all the images in, asset server load for all of them. I throw standard material, manual MIPS. I'm basically taking the biggest one, running a function called build MIPS on it, or rather this is a system. And once all of these are loaded, it stuffs all of these in to that image, and then says, treat these as MIPS, please. So it's a little bit hacky, but it gives me the ability to have completely different textures, or completely different solid colors for each MIP level. So obviously nobody's going to do that. So the question becomes, if I'm going to make a video on Mipmaps, you probably want some practical usage. And that gets you into things like KTX. So this is a KTX file with a 2D texture array inside of it and 12 MIPs for each of the textures. So this is effectively like one KTX2 container file that contains effectively 12 times 3 images, where each of the Mipmaps or MIPs or whatever are for each individual. If we zoom in here, you can see what's happening. Like these are the full resolution, like 2048 textures. We can zoom in quite far, and you can see like all the detail in here and whatnot. If I go over to the tiles, you can see all the tile grouting and whatnot. So if I start going down, this is going through each MIP, and kind of every time we see one of these horizontal lines here, we're decreasing MIP quality. So you can see, even though they're showing at the same like size right now, they are decreasing in resolution. So we go all the way down to like these, which are barely even recognizable as the things that they are, right? This is 4x4. This one's 8x8. This one would be 16, 32, 64. And then it gets hard to kind of like start counting them because it's harder to see them. But creating these files and coordinating these files is not particularly well known. So I got into doing that as well. And I did a whole bunch of, let's see. Here are the raw assets. The raw assets come in as PNGs. So this is just one full 2048 by 2048 color texture for those tiles, right? And then because I'm using Substance Designer, it's going to show me the UI and not show me the image, huh? Here's our normal map for those tiles. We also have depth for those tiles. So depth is grayscale, right? It's just one channel. Normal map, 3 channels, RGB, or XYZ actually. Color. We have metallic roughness in here. I'm not currently using it for anything, but we have these for every individual thing that I'm working with here. So the question becomes, if you've done this work in Substance Designer, right? So I think I have Substance Designer open here. Yeah. Can I bring this over? I don't even know. It's going to be an adventure. Let's minimize Blender. We don't need Blender right now. So Substance Designer, if it wants to stay on that monitor. I don't know how to make the Substance Designer UI bigger, so I'm sorry about that. Lot of UI here. I can zoom in on this though. So basically we've got a couple of graphs. Here's our, let's go with the floor graph. So we take these things, we are putting them into these outputs 2048 by 2048. This is color, 8-bit, etc., etc. You can see that this is the depth map. It is lightness or luminosity, sorry, is the L that they were used here. And you can see a preview of these textures like on this cube here. But basically, once you do this, you hit export. This creates a bunch of PNG files. Those PNG files are the ones that we're looking at here. So this is the texture that you get out of Substance Designer or Material Maker or, you know, whatever other texture creation tool that you want to use. And the question is, what do you do with this? You have the PNG, you have all the color data. You want the Mipmaps, and you might want other things as well. So there's a number of different approaches. We can't preview basis files in VS Code. That's fine. But these aren't really the ones I want to show. That's also not the one I want to show. So if you use the tool that I'm using, Cram, to build these KTX files, you cannot view them in VS Code right now, which means that we have to go back to this application. This is CramV, and CramV will actually open a KTX and show us everything that's inside. The UI is a little bit hard to use. All of these are like single letters. But it's kind of nice in that you can like view individual channels and stuff. So this is R, G, B, and A for each of the images in here for all of the MIPs, which is very cool. Let's see, can I open... this one? So here's an example of... do I want to talk about compression yet? This is an example of a compressed normal map. Let's first mention... here's my blog post that I'm writing on all of this stuff. Way too many windows open. If we look at the normal map here, the normal map for the floor will be RGB, right? So it's a tangent space normal map. So XYZ in tangent space, we see a lot of blue. Using the tools that we're using, you typically, if you're going to process them into KTX, you're going to also want to compress them. This uses a compression algorithm for the normal map to turn 3 channels into 2 channels, and then in the shader you use a calculation to get back out to 3 channels. So if I have that example here. This is the logic for pulling that back out. So if I run this, you can see that there's RGB, and we can see that they're all in the right spot, right? Like the PNG is on every face of every cube. This is a visualization of the normal maps having been compressed into 2 channels and then re-expanded in the shader back into 3. So the question that I had that I'm working on at the moment is, well, let me mention one more thing first. So let's get out of cram. The processing that I'm doing, I've gone through a number of different tools. So there's KTX tools. This is an unrelated tool called OpenImage IO, I think. I went with Basis U at one point. Basis U is very cool. That's Basis Universal. Basis Universal is an interesting thing because it's like this universal codec that you store inside of a KTX2. So you run Basis, it builds this Basis codec format of the data, sticks it into a KTX2 file, and then when you send that to a GPU, or you load it into Bevy and you send it to a GPU, you do a very lightweight transcode into one of these compression formats, and then send it directly to the GPU. So you don't do a full decompression, you just transcode it and send it. So that brings us to where I am right now, which is basically we have CRAM. We're using CRAM encode. In this case, we're using BC7. That's block compression 7. It's the name of an algorithm. BC7 is kind of what you would use for any sRGB color. So this is base color in this case. We are super compressing it with Z standard. So GPU textures and compression is kind of like overpacking a suitcase and then getting a friend to like push it in while you push it down and try to close the latch, and then on top of that getting another friend to like stand on top of the suitcase while you try to close the latch, and then once you do get the latch closed, like taking it over to that hydraulic press that was really popular on TikTok, and then compressing it again. So we end up with like compressed textures in the first place using BC7, and then we super compress them with another algorithm on top. So it's compressing compressed textures. And in this case, we're just creating a 2D image. So CRAM encode, use BC7 because we're going to do an sRGB. This is going to be the base color texture. This is just a 2D texture, regular PNG style image. sRGB color space, or sRGB like space data. Super compressed with Z standard, output to a KTX2 file, and input from that base color PNG. So this is the command that you're going to run for all base colors, for all standard materials, for all Bevy stuff that you create. It's a little bit complicated in the sense that like there's a lot going on here, but once you get this command, you can run it for any base color, for any texture, for anything, and you get a compressed version of that as KTX2, super compressed, compressed with BC whatever, that you can send, which is good because the smaller these textures are, the more of them we can fit into memory, the better the games look. So we were looking at the normals a second ago. That uses a different algorithm. That's BC5. So we're using CRAM encode with BC5, which is that 2-channel compression. It's actually 2 channels of BC4. We say it's normal, it's 2D, we super compress with Z standard, yada yada, output to a KTX2 file, input that normal map. So the thing I was doing with this is what I showed before. Here's my test. I was testing specifically, not layered materials, just run. I was testing specifically if I could figure out how to get that third channel back out. If I go to this post that I'm writing, I have a grid. Basically, BC 1, 2, and 3 are old. Kind of don't use them. You can use BC 1 if you know what you're doing and you want a really small texture. And you're okay with something that's a little bit lower quality. BC 4 is one channel. So it's for grayscale images or that depth map that we had before. So we'll be using BC 4 for that. BC 5 is 2 channels of BC 4. So that is for normal maps, which sounds a little weird because normal maps are 3 channels. But what happens is they get compressed again into 2 channels. And then in the shader, it re-expands it to 3. And then BC6H is for HDR. That's for light maps and stuff. There is no alpha for BC6H, but BC7 is kind of like if you don't know, using BC7 is fine. That's RGB or RGBA for general base color usage. So the next thing I want to do, I'm trying to figure out if Bevy knows how to do this calculation here or not. That's what I'm really interested in at the moment. So what I was trying to do before stream is... Do I keep Xing out Chrome? That's why I can never find Chrome. I close Chrome instead of leaving the window around. Let's go GitHub Bevy. If we do something like search for BC5, right? So how would you find this code at all? If we search for BC5, inside of Bevy image, there's a KTX2 file, .rs, KTX related file. And in this case, it says color model BC5. And this can be BC5, RG, UNorm, or SNorm. Those are unsigned 0 to 1 or signed -1 to 1. That's all they mean. You get these 2 channels, RG, and they're either going to be 0 to 1 or -1 to 1 in the shader. If we go to the top of this function is, if I remember correctly, texture from the header format. So KTX has a header format. We can go down to the usage of this. It's used here and just blanket returned. So this is KTX2 get texture format. Get texture format then is used here. And you can see that we've got some transcoding code here. If you were using something like Basis Universal or whatever, that it gets handled here specifically. But we don't have that. So we end up with our texture format. It goes into the image. The texture format gets set on this image. The data order for the order that our Mipmaps are in, our MIPS, is actually MIP major, hard-coded. This creates an extent 3D for the image size. We've got the number of MIPS that we have in this, because you could have any number. In our manual example earlier, we had about 5 MIPS, but in the actual processed files, we have 12, because it costs us nothing to do that. Well, it doesn't cost us nothing, but we don't have to manually create each of those images. They're just getting sampled down, sampled down, sampled down. So that's it. We just get the texture view descriptor, with this image, with all these settings, all this metadata. And the image data is just set to the image data that was in the file. So that texture format actually comes from WGPU. So if I look for texture format, and feel free to ask questions, because I know there's a lot of like acronyms, a lot of stuff like that going on. So let's look for BC5 RG. So these come from WGPU. As you can see, they are texture formats that the GPU recognizes. We don't have to decompress all of these to send these compress textures to the GPU. We just get to compress them and send them. All of the block compression algorithms, all the BCN, BC4, BC7, whatever, 4x4 block compress. There's some other information here about how much space that takes up and whatnot. The important thing is that this is red and green channels. And it's converted to float 0 to 1 in the shader. So this is what we have in the shader. We have 0 to 1, 2 channels, RG. So this function at the end of the day is called KTX2 buffered image, which, surprise, surprise, we can also go look for. Where is this? KTX2 buffered image. So KTX2 has all that implementation detail, and if we go to Bevy image, Bevy image calls this if the image format is a KTX2. So this is give me the image based on the format. This is image from buffer. So at some point we're trying to create an image. We have some data. This determines what that data is going to be based on the container file format. So KTX2 is a container. It's not like the codec inside. We run this function. It gives us back an image. And then what is this sampler actually? Sampler gets passed in. Interesting. Sampler is something we can modify when we're doing an actual image load. So if we go back to the actual code, I think I'm doing it here. Yeah. So if you have asset server load with settings, you can load one of these KTX2 files. And in this case, it's a normal map. So we set is sRGB to false. Hey, crowds. How's it going? I'm rambling about texture compression and GPUs and stuff. It's also like the end of my day right now, so I'm a little scatterbrained. So, this normal map, as we covered, has 2 channels because we compressed it using BC5. Those channels are R and G, sorry. If we look at the shader basically does the sample on that material. This is nothing special. We're just passing this in like just as a random texture, random image. This is not being like prepped by some special pipeline or anything. It's just an image that was a KTX2 that we passed in here. So we get RG, which are the 2 channels we have. We do these calculations to get Z back, and then we're just returning that color. If we wanted to look at just the blue channel stuff, this is what just the blue channels look like, ZZZ. But the other thing I wanted to do is look at the standard material code and look at the normal handling and see if there's handling for this already. I don't actually know the answer to this, so we're doing this together. I have a hunch that the answer is actually no, that it doesn't do this. So we're in Bevy PBR, probably in render somewhere. Maybe in PBR for standard input, which is a WGSL function. PBR for standard input would probably be in PBR functions, if I remember correctly. Bend for anisotropy. Anisotropy is another thing that I'm going to do in the Mipmaps stuff. Apply PBR lighting. Let's just look for PBR input, main process, screen space. It's not in this file. Which file is it in? Is it in It's not in types. These are just types. Bindings. I thought it was in functions. Can also just look for it. PBR input from standard, or from, I forget what it's called, from something. From standard material. PBR fragment. Yeah, it is. No, this is function. That's why. It's in PBR fragment. So PBR fragment.wgsl. This should have then PBR input from standard material. So this is where I want to start. This is the same thing that we would call from a standard material extension. So it's nice that this is just hanging out here. I don't know what this is going to do. We're looking for normal handling. We're looking for it to see if there is automatic BC5 handling. I feel like there should be, but I feel like there won't be for some reason. So parallaxed UVs, the base color, etc., alpha mode, bindless stuff for attenuation and reflectance and stuff, the index of refraction, meshlets, material, emissive colors, metallic stuff. I hope this file gets cleaned up a lot when we move to Weasel. I get kind of lost in the if-def soup. Generally speaking, Bevy does a pretty good job of like labeling this as like the end of one of these with comments, but it's still kind of awkward to read for me. It still throws me for a loop every time I see it. Here's a normal map. So if-def standard material normal map. Apply normal mapping. Maybe that's where we want to look. Those are in PBR functions. So PBR functions, apply normal mapping. Standard material flags. That's another thing we should look at, actually. Let's look at standard material flags. Bit flags, yay! What are we going to call this? Two component normal map. That's what we're looking for. That is what we're looking for. I expect this flag to be set. Sorry. I expect this flag to be set in those flags when this normal processing is happening. If we see the two component normal map set, that means that it handles the RG that we're passing in. So standard material flags here. Apply normal mapping. This is where the normal mapping is being applied. And here we go. Standard material flags, two component normal map. Only use the XY components and derive Z. So the logic here, the normal times 2 minus 1. So if you are a person who has done a lot of like simplex noise, Perlin noise, that kind of thing, this will look very similar or very familiar to you. What this is doing is taking a range from 0 to 1 and turning it into a range from -1 to 1. That's it. If you multiply 1 by 2, you get 2. Minus 1, you get 1. If you multiply 0 by 2, you get 0. Minus 1 is -1. So it's just changing the range from 0 to 1 to -1 to 1. Then this square root is the same calculation, I believe, that we had in our other code. So square root 1 minus dot on the xy's. So slightly different here. Slightly different method of calculating it. But effectively the same thing. So that sets Z. So that's good. So the standard material should be able to handle these two component normal maps just fine, which I think is accurate. I do want to see this get set somewhere else in the code. So I want to look for this somewhere in Rust code. That's the definition of it. Looks like it's where it gets set. Has normal map. So what function are we in here? This is as bind group shader type for material. Cool. So as bind group shader type material uniform. This is the data that's going to get passed in. So has normal map. If there's a normal Mac Miller. If there's a normal map texture, then get the EID for the handle. Get the image. So this is the actual texture. Check the texture format. This will be our texture format. BC5 RG unorm. That's what our compressed normal map is going to come in as. And then that means that the standard material flags are going to have two component normal map set. So everything's good. It should all work. We've confirmed both in the shader code and in the Rust code that the 2-component normal map will just work. There's no extra stuff that we need to do. However, there's one more thing that I would want to do before we get out of here. That is out of these files specifically. Apply normal mapping. And let's take this code specifically. And I want to see the impact of that instead of this. So NT here for us is post XY. And that doesn't look a lot different to me. So it does feel like these are the same calculation. Which makes sense. It's a dot product with itself. So I'm happy with this. This is good. These are good things. That means that, where's our other example? Layered materials. Where's the... Oh, it's full screened. That's why. So if we look at our main.rs for this example is trying to use the 2-channel normal map that we created and the BC7 base color. Hey, Kaiman, how's it going? So, again, BC7 compression with Z standard into this KTX2 file. We're using that as our base texture. BC5 on the normal map, also compressed with Z standard, also in a KTX2 file. So, this should just work. So we're going to run the bin, layered materials, file watcher, etc. And we should be able to see lighting happening here because we have our normals. I think I'm also calculating the tangents. Let me check. Yes. So also important to make sure that this circle is built with the generated tangents, but that's easy enough here. If you're exporting this from like Blender or something, that's a checkbox in the export, including the tangent data. So this is a pretty good image so far. This is some lighting information and whatnot. We also have depth for this image. So given our script, for creating these files. We have the raw assets sitting around here, right? If I look at the floor depth map, this is the depth map. We can see it's single channel. We can see its grayscale. That means a BC4 for the compression algorithm. So let's copy this, not create a new file. The one downside of these commands is that they're so horizontally long that it's really hard to show them all on screen at the same time. Okay, so we've got cram encode. We're going to use BC4. This is not a normal, so I think source lin is the actual command or actual option to cram that we need to use. We are not going to use normal maps here. These are going to be depth maps. So we're going to call this depth map, and we're going to call, not going to select other random stuff in the file. We're going to depth map here. So I'm using new shell. You probably aren't, but this is a new shell script. You can also do this in a shell script, something like that. Let's run process images, and in process single, base color came in. Normal map came in, depth map came in. So I think that we won't be able to view this directly in VS Code because it's using that compression again. Right? The KTX tools just kind of fail to extract this from the KTX file. So what we're going to do instead is use cramv. And I'm going to take the depth map and I'm going to drop it in here, and that looks okay to me. Right? The really nice thing about cramv is it will give you a whole bunch of extra information. I can actually look at like which pixel is here, etc. And it'll actually show me the values. So it's going to be hard to see because I don't think I can make this any bigger. See, let's try. Nope. That's one of the downsides about tools made for people who don't do UI stuff is that you don't get UI affordances. I have no idea what this application is built with. But in the top left of the screen, like top left, it says LIN and then a number there. So as I'm dragging this through, we can see the different numbers here, especially in the grout, it changes. But on the faces, it's pretty consistent. So that's good. I think we have what we need there. So let's go back to our main.rs. Let's go back to our asset server load calls. And we are going to enable the depth map. This is using process underscore single. I think that's just a name that yes. So I'm going to get rid of that folder. We have process dash single. Sorry, I wish these things could be appropriate size for stream and also not flowing off the side of the screen, but when somebody invents triple monitor streaming, I'll let you know. So we got processed single here with our depth map, our normal map, and our base color, all packed as KTX2s, all with a different block compression algorithm. We've got 7 for the color, 5 for the normal maps, which is 2 channel, and then 4 for the depth map. So let's check the size here. If we can, if my monitor. So base color 4 meg, depth map 1 meg, normal map 5 meg. Those are pretty reasonable. So all things considered, this should run. And I think that's okay to me. It should be using parallax depth here. And I think it is. It can be a little hard to tell sometimes. But if we go back here and we say depth scale, I don't know, something massive like 4 or 0.4, sorry. You can see that it is actually using that data. 0.4 is just not the right value to use, as you can see here. Things get really wonky. If you use the wrong values. I think 0.1 is the default. But because of the way this scene is set up, that wasn't quite what I wanted. Because we were getting some of these duplicate lines here with the way that the parallax is implemented. So it is really important to get like the parallax depth scale correct. And that's, if I remember correctly, based on the texture size, not 0.05. We were at 0.2, but I think that was pretty arbitrary. So we can still see this as a little bit weird. I think the other thing is that we currently don't have this as a repeating texture, which you can kind of see far off in the distance. So this is looking pretty good overall. These are all compressed textures. They take up less than 10 megabytes, or about 10 megabytes all told. Pretty good overall. So my suggestion for the Mipmaps video, and for if I do like a KTX or GPU texture video in general, is going to be use Cram. Cram is probably the easiest one. Is it the easiest? I think Basis might be the easiest, but configuring Basis is kind of not something you can just intuitively do. So Cram is the tools we've been using to do the compression, basically. It calls out to these other CLIs and stuff, as far as I'm aware. We've used Cram and CramV, or Cram, not exe, but .app, CramV. Oh, generates Finder thumbnails and quick look previews? Sweet. I didn't actually know that. And it's a wrapper to several popular encoders, yada yada, with some particular configurations. So in the end, Cram seems to win out. The other options are things like KTX Tools, which is the Kronos texture library and tools. That's not the page that I wanted to click though. Which has a bunch of things like KTX Create. KTX Create will pack these files in for you. Hey Xavier, how's it going? Texture compression today, which I know is everybody's favorite topic. Also feel free to ask questions about Bevy and stuff like that. But I've been looking at texture compression a lot this week, and my mind is swimming with acronyms. So there's KTX Tools. There is Basis Universal. Basis Universal is actually really interesting. But I've found that it doesn't seem to work that well on like normal maps, for example. So if you are looking for something that is a fairly high compression for colors, Basis Universal can kind of be okay. Also, everything that we've looked at so far is low dynamic range, so there's no HDR going on here at the moment. Basis also gets packed into a KTX2 file. It can also write out a .basis file. They have their own file format. But KTX2 is an open standard. It's supported by all these tools, which is really great. The only thing that's really a downside of KTX2 is that you can't export it from Substance Designer, Material Maker, what is it? Instamat. Like, programs don't support KTX2 as like an export format, which is really unfortunate. It would be really cool if it did, if that was the way it worked. Because then you kind of wouldn't need these tools. Basis Universal, before we get off this page, is really, 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 really cool. It's super compressed format. You get two options. You get effectively like ETC1S, which also uses Basis LZ, and HDR, or UASTC, alongside Z standard for super compression. Hey Anders, texture compression today. Mipmaps texture compression. Your GPU does not support KTX2. How old is your GPU? Which GPU is it? I feel like KTX2 is pretty well supported. See if I can find a reference for that. I'm curious as to which GPU you have, though, that doesn't support KTX2. GTX 970. Okay, yeah. $2014. That's a decade-old GPU. Actually, more than a decade. So... yeah, I mean, I feel like it would be hard for me to say that a thing that I was going to ship, I wouldn't use KTX2 because of that. I might do a second build. Yeah, I know. I lost count too. Last few years have really compressed. Speaking of compression. Yeah, I think a decade-old GPU is one that I probably wouldn't target with the main live build. I guess you could try to do some other stuff. You can definitely build some of these things like inside of Bevy. We did that a little bit at the beginning of stream. Taking Mipmaps, or taking MIPS from different files, loading them in using the asset server, and then packing them all into the same image. You can absolutely do that. So there are fallbacks, but a decade old is pretty old. Anyway, the cool thing about Basis Universal is that you pack everything into this Basis Universal type, stick that into KTX2, and then a very light transcode happens at runtime from Basis Universal to, BC7 if it's an sRGB, or BC5, or whatever, which I find very interesting. What else? There's NVIDIA Texture Tools. NVIDIA Texture Tools is also a way to create these KTX2 files. I'm streaming on a Mac right now, so can't show this program, but I did use it the other day, and it does work. Very cool that this is supported, the two-component normal map. So altogether, that is a single KTX2 image set, right? So this is like the set of textures that you would use with a single material. We've got our base color in our KTX2 compressed, normal map KTX2 compressed, depth map KTX2 compressed. The other thing that I didn't show that we probably could show is Cram has a info command. So if we do info on the base color, oop, that's the wrong path. Let's see, single base color. So if we run cram info on that generated KTX2 file, we can see a lot of information about it, how big it is, the compression, like the super compression for Z standard. It's a 2D image, 2048 by 2048. 12 MIPS, BC7 compression, etc., etc. Like the things that you would want to know are all here, which is very cool. So if we run this on, let's say let's run it on the normal. We see something very similar, but we see that the format is BC5 instead of BC7. And then running it on depth should show BC4. If we run this on an array, which I think this one's going to be, yeah. If we run this on a texture array, which is another thing that we're going to get into in a second here, you can see that this is now not just 2D, but it's 2DA, so it's a 2D texture array. It's still got 12 MIPS, but it's also got 3 images in that texture array. And it also uses BC7 as the compression for those images. So this is good. We like this. I'm going to comment this out for a moment. I don't know if I'm going to do more. So metallic roughness is another interesting one. I think metallic roughness would also end up being BC5 because it's 2 channels, metallic roughness. But we don't have any metallic roughness information in any of our textures right now. So it's not even worth really investigating at the moment. Right. This empty. Metallic roughness, empty. Metallic roughness, empty. Yeah, we don't have any metallic roughness information. I kind of left that in there because I was creating a substance designer like Bevy output template, which can support metallic roughness, but that's another thing. I wonder if the metallic roughness, like it is 2 channel. Yeah, because it wouldn't be compressed like the normal would. So this is supported by default by Bevy. So let's comment this out and take a look back at our texture arrays. Now we haven't seen the texture arrays on screen. This is going to be our final like single winner. So most of these are going to go away. Let's get, actually, before we do that, let's get rid of these extra create calls. Right, so we're creating these 3 files. They are BC7, 5, and 2. Let's move these over so that some of this stuff lines up. A little easier to read in case anybody comes in here and is like, oh, what does this do? Unrelated, but thinking of that yesterday, does Bevy support dual quaternion skinning? The preserve volume option in the Blender armature modifier. You looked and you think it is not the case. I don't know the answer to that. I have no idea. I know that there's a bunch of work that people want to do, might be the way to phrase it, on the animation system and things like that. So I don't know. A quick way to approximate spherical interpolation. Nice. So let's comment this out. The thing we do need here is, I think this. So this one is dumping into processed array cram. We're going to end up getting rid of a bunch of these folders. A bunch of these folders are going to go away. The reason I'm so interested in the compression is because all these files are going to go into this repo. And some of these 2D texture arrays get pretty big. So compressing them and putting them into the repo as compressed textures would be much, much nicer. It's also a little bit more real world. Let's get rid of the uncompressed. We've got process single. Let's leave these until we get the cram stuff working. Let's get rid of a bunch of these. Oh, if you do end up having a KTX file that does work with the VS Code viewer, it's pretty cool too. Like you can, it's a little slow actually, because it does a full extract. But you can switch between the layers. So this is a texture array, a 2D texture array. And if I go to 1 and wait a second, it extracts and shows. If I go to 2, which is texture array image 3, I guess. Anyway, same thing with MIPS and stuff. But we're going to get rid of these files. These are all going to go away. So we've got our raw images here. And we've got an empty processed array cram folder. So we already have the things that we need to do, right? These commands here. So let's take each of these. Maybe we'll Shift Control A. Yeah. So process to processed array cram. The interesting part here is that we are now working with 2D texture arrays, right? So to do that, we can't actually throw PNGs, multiple PNGs into cram at the same time. So the first thing we do is take our PNGs and throw them into a KTX. And then we take that KTX and we create the 2D texture array out of it. The spherical interpolation to avoid the candy wrap stuff that happens when you twist a bone. The candy wrap stuff. Yeah, okay. Interesting. I don't know how it avoids that. But I'll look it up for sure. That's interesting. So we end up with floor, grass, stone PNGs go into this KTX2 file. 3 layers. We're using KTX tools here to create RGB with an alpha, all 8-bit, sRGB, and then we do BC7 2D array. Right, basically this command, sRGB, Z standard. Let's leave Z standard at 0 for now. Perfect. So this is it. We end up with an output of base color.ktx2, and then why are we inputting array base color? I feel like that's wrong. Oh no, it isn't. It's correct. Where are we creating this file? Into target array base color. Cool. Let's call this uncompressed base color. That seems like a better name for it. And then I think we have to do the same thing for the others as well. So we'll have to pick some Vulkan formats, which is going to be a little bit annoying. So these are all going to be base. normal map, I think is what we call these. And then this is going to be the same thing, but it's going to be depth. Right? So we will end up with 2D texture array, 2D texture array for normals, 2D texture array for depth. Everything ready to go. We do need to pick our inputs and our outputs for each of these. I started writing the oh, this needs to not be array base color. Didn't we just change that? Did I not just change that? Grass, stone, array. Didn't I just change this to uncompressed? I definitely did. Okay, I'm losing my mind a little bit. So we're going to make this uncompressed. Come on, VS Code, you can do it. Normal map, uncompressed depth map. And then we need these two to be the names of the outputs. So we'll grab this. This is going to be normal map. This is going to be depth map. We're going to grab our two names here and stick them in our two positions. Okay, so we should have at this point 3 uncompressed KTX files from a set of PNGs created, and then each of those KTX files should get encoded with the appropriate format that we just used for all the single. Now the only difference here is that we need these to be 2D arrays. So we should end up with 3 2D texture arrays, 1 for base color, 1 for normal map, and 1 for depth map when we run this. And we'll get rid of all of that. So this should just work. So let's get out of code mode and let's get a process images going. Let's take a look at the folder. So this is the cram folder. So we should end up seeing 3 KTX files show up, uncompressed base color. I've got a little warning here. No transfer function can be determined from 8-bit PNG input file. Defaulting to some transfer function. We do need to set the VK format for the normal map. It seems that we have a 16-bit normal map. And then same for depth. So if we keep these, we're going to lose some data. Oh, that's so cool. Just preview right in Finder for the compressed normal map, compressed depth map. Just the red channel on that depth map. That's so cool. But what was I saying? We are using the wrong formats here. So the place we get these format names from is actually the Vulkan texture formats. And this is a scary list. This is a huge list. So what do we have? We have, I think, R16 unorm for depth. red channel, single channel, unorm. So this is depth. Let's use R16 unorm here. And then the question is for normal. When we first create the normal map, we're going to end up with 3 linear 16-bit values. So I think we're going to want R16, G16, B16, unorm. And this is where it gets a little bit annoying, because if you theoretically could just give Cram all of these PNGs, you wouldn't need to go to this Vulkan texture formats list and then find the right one. I think this is correct though. Now we are seeing some warnings, so let's take a look at the warnings first. KTX create warning. No transfer function can be determined from an 8-bit PNG input file. Defaulting to KHRDF transfer sRGB. Use assign TF to override. So let's go look at the KTX tools. Reference, KTX create. We'll look at assign TF. Force the created texture to have the specified transfer function, ignoring the transfer function of the input file. I think we have to specify the format, which is causing this. The options are linear and sRGB, or a whole bunch of other things, none of which I think apply to us. Interesting that there's an SMTPE 170M. SMTPE is like video timestamp encoding. Interesting. So we're going to need linear and sRGB are the two. So let's drop in assign TF sRGB here and assign TF linear for the other ones. Right? And then let's get rid of all the data in here. Move to trash, process, and hopefully we don't get any warnings, and hopefully we get all of our files. Those are the two things that we're hoping for here. We've got the uncompressed base color, which is just 3 PNGs packed into a KTX file. Nothing special. Ooh, unsupported texture format, BK format 84. Let's go look at Cram. Interesting. Very, very interesting. So let's get rid of, I think 84 is the normal map. So let's comment the normal map out for a second. Comment out the sRGB. sRGB, the base color should work, but we're going to still test the normal. Okay, R16 unorm also doesn't work. It's very, very interesting. KTX create help. Right, format is required. The KTX format enum that specifies the image data format. enum names are matching the VK formats without the VK format prefix. When used with the encode, it specifies the target format before the encoding step. In this case, it must be one of interesting. The other thing is, like, it's not entirely clear what kind of data you end up getting. So if we look at this, right, I just used R8 unorm. Possible loss of precision with converting 16-bit input to 8-bit output. So we have 16-bit data in the PNG. I think 8 and 16 are the only two that PNG can hold. Unless, hang on, let me check my math real quick. PNG. Okay. I also have EXR files laying around, so I just wanted to make sure that I wasn't processing the EXR files. 8-bit versus 16-bit. I don't have like a PNG info command that I'm aware of. Cram. What's the issue with cram? I guess the other question is, are we going to lose precision if we do this? I think I wonder what formats cram supports. I don't know how to find that out. We can definitely just run cram on its own, and I think this will dump the usage. Yeah. I always find CLIs that are built with the single dash here flags confusing compared to the double dash flags. So format, BC whatever, Z standard, source lin, encoder, resize, MIPS. Does MIPS by default, which is nice. Normal is what we're using. Z standard. Also important to notice that Z standard 0 isn't 0, it's just default. So cram info, cram decode, cram script. Don't get any more information, right? And what is the actual error that we get? Not for the R8, but for the R16. Unsupported texture format. Because one of the things that I've run into a couple of different times, not this error specifically, but just that like the texture tools overall end up having like a missing stair here, a missing stair there. Like it mostly works except for the edge cases. It also kind of just expects that you already know what you're doing. They aren't tools that teach very well. So what is, there's no PNG info command, right? How do we get the metadata of a PNG? Identify. I think that's image magic tool, right? So identify assets, raw assets, floor, depth map. 16-bit grayscale. So if we have 16-bit grayscale, R16, how is that unsupported? I guess the depth map before was not actually R16, it was like Y16 or something like that. Let's see, what else do we have here? Look for what it has to say about R16 formats. R16 unorm specifies a one-component 16-bit unsized normalized format that has a single 16-bit R component. The question is, I don't actually know off the top of my head how PNG stores this data. The only 16-bit pixel format in PNG is a high precision grayscale without alpha. Yes. I don't think we have anything here that would be gray. Yeah, there's no grayscale. It's R16. I guess technically the image is like a Y16, not an R16. That's very interesting. So it can handle 16-bit grayscale PNGs directly, but it can't handle them if they're packed into a KTX2. What is our cram command doing? Our cram command is encoding with BC4 2D array source lin. I think the data just has to be in the right format. Cram encode help. Cram encode help. I don't think we're getting much information here. So the question is, cram. Why doesn't cram support R16 in a KTX? Let's see, formats. What's the previewer? Encode Mipmaps. The interesting thing that I haven't looked into is that says fast SDF. I don't know how it stores SDFs. That's really interesting. At some point I want to look into that. But it says it supports 16F. Encode, decode, block formats. Pre-multiplication, sRGB, swizzles, LDR, HDR, 16F, 32F. Why is R16 unorm not supported? I'm going to try this just out of curiosity. Input file PNGL does not match the expected input byte of 32-bit sfloat for R16 uint. 32-bit sfloat. For R16 uint. And that was, which program outputted that? Was that cram? KTX create is what that was. PNGL. Image input format type, PNGL. Luminosity alpha, RGB, RGBA, EXR uint or EXR float. I don't know what MPBM is. JPEG. So this is probably the list of everything it supports. We currently have a PNGL. There's no issues. Are there any issues on this repo at all? Yes, there's many issues on this repo. Okay, let's do... let's try to search for something like depth and see if somebody is just talking about it generally. KTX is source and destination for HDR and encoded. Photoshop. There is a Photoshop plugin, I believe, that exports KTX. Is that right? I think that's right. We all agree more tooling is needed. Yeah. Cool. Oh, this is the person that built Cram. Oh, that's sick. GitHub Actions, yada yada. Corresponding Open Image I/O feature issue. That's basis universal super compression. That's not the thing we're using in general. .3D textures, sRGB, depth, PNG with 16-bit channels aren't supported as inputs when using super compression. I've seen this person before, Zooks. Blah, blah, blah. Basis ETS, yep, basis universal, that's exactly what I would expect them to be talking about. The reasons for KTX invalid operation at the point of the printf are as follows: super compressed, block compressed, a packed format, component size is greater than 8-bit. I feel weird about having a 16-bit PNG and potentially cutting it down. Converting to 8-bit automatically is the best option without a warning, since super compression compromises quality. Endpoints are something that are related to the compression algorithms. Palettes and endpoints and things like that. Supports 16-bit and paletted images. Okay, so it's supposed to work. It does work if you pass it to Cram directly. This is the KTX tools repo that we were looking at. So the question is, 16-bit data in a KTX container is the issue for Cram, but we need to pack it into the texture array 2D for it to be what I want it to be. We can't pass multiple input files to Cram. That's not how you spell any of that. If we use R8 unorm, maybe we just encode it to 8-bit. Feels weird. Feels weird to do that. We can almost certainly do that, but it feels weird to do that. Okay, let's check the other one as well. This is the other problematic format because it's also 16-bit. Yeah, unsupported format 84. And if we do identify on the normal map, we get a 16-bit sRGB. sRGB? Why is that sRGB? Interesting. That's not how I expected the normal map to be encoded. I thought it was going to be linear. I'll have to dig into that. The base color is 8-bit sRGB. Why is the normal map sRGB? That feels really weird. Let's do another test. Assets, raw assets, base color EXR is RGBA, floats. I think EXR is really only good for HDR content. Especially the way Substance Designer dumps it out. You can see here that we've got an EXR with a Y channel float. This is the depth. It uses Y as like a luminosity stand-in for the channel name. That's interesting. Why is that sRGB? (16-bit sRGB). I think I set this to raw when I exported it. So one thing that I do want to try here, now that I'm aware of this potential issue, let's grab Designer. Let's go to the floor graph and export outputs. And here we have base color as sRGB, but the normal map is raw. What if we do normal map as linear? And I kind of want this to go into a different folder. So I'm going to stuff it there. Export outputs. Those should be exported now. So the real question, this is the other problem with Designer, is it really likes being on every desktop. Okay, so let me do identify then on whatever folder I just named this. Linear normal map. Base color. It's going to be sRGB 8-bit. Normal map. 16-bit sRGB still, even though I selected linear. It's interesting. It's interesting that these are 16-bit. It's interesting that this one is sRGB. The other one's grayscale. Right? What is the metallic roughness? We don't have any data in here, but this is 8-bit sRGB. So, Very strange. Very strange that Substance Designer gives us different files. But it doesn't really tell us anything about the data inside of it. That we can't use. So I wonder if this is sRGB and not linear. Let's do unsupported texture format back to the CRAM repo to see where this error message comes from. Because now I'm curious about the full list here. Like, what is actually supported by CRAM? For base color, it's definitely the go-to suggestion, I think. Quote this so that we actually get the full. Early returns on unsupported texture formats. Format table has a list of formats. Where's the format table? The idea is to use KTX2 and Z standard super compression with Photoshop instead of PNG for explicit R, RG, RGBA textures, and then feed those to the encoder to get KTX2. The RGB 8, 16F, 32F formats don't exist in metal. CRAM supports KTX and KTX2 with or without Z standard super compression. The L is linear, it indicates the sample is linear. Ignore the transfer function. This definitely feels like deep diving. Unsupported texture format. There's two places. Yada yada. The following table could be included multiple times. BC, block compression, ETC, ASTC, EXP. Okay. Let's look at VK format R16 S float is supported. So let's get rid of this for the moment. Let's go back to this and let's say that this is S float. We process PNGL is not an S float, which makes sense because it's not, as far as I'm aware. I think it's a uint, but that's not supported somehow. Look at R16. Import only formats. VK format R16, G16, B16, S float. I don't think we have that. KTX data isn't fully packed on explicit formats like R8, RG8, and R16F. DXGI formats. GLR16F. We don't have that though. We have, I'm pretty sure, UNorm. Well, we have R16. UNorm is how it would be in the shader. Really strange, it feels like. It can operate on the PNGs directly, so what is it doing to the PNGs when we give it to them? Right? Is there a PNG folder? Load PNG. CPP. Load PNG. Let's look for 16 for a second. This just looks like a... nothing interesting. This is just a PNG parser. I don't think this is important. Load PNG. Z standard transcoder. I feel like I'm not sure what to do with a 16-bit PNG that we get from Substance Designer to pass it in this way. I don't think CRAM can handle creating the texture array 2D itself. I think it has to receive a texture array 2D, so we have to pack this into a KTX anyway. Previously, I was doing that in a hilariously incorrect way, as far as I'm aware. Right. Let's see, KTX create. Encode. Encode is basis, LZ, or UASTC, which are the ETC1S and like basis universal formats. We don't want that. That's not what we're looking for. KTX format specifies the data format for the images in the created texture. So the question then, 2D array source lin. We don't specify any channels or anything in cram, so it's a little bit weird. Right, cram encode BC4 2D source linear Z standard, and it just takes the 16-bit PNG and just dumps it into the KTX. So the KTX here is the depth map. Let's do a KTX. No, we can't do the KTX info. We have to do cram info. Cram info on the depth map. Could not be opened for read. Why not? Process array cram depth map.ktx. Oh, because that doesn't exist currently. We're not looking for the array. We're looking for the single. So this tells us we've got BC4, 12 MIPS, 2D. Nothing really about the data. If we open this in cram-v, so process single depth map. This is info. So this is the same, this is cram info output. Cram Vulkan format 139. What is Vulkan format 139? Where is the list? 139? 139? BC4 unorm block. Because we've compressed it. Which makes sense. If we don't compress it, what do we get? Right, so let's grab this. We'll throw it over here. Oh, that doesn't work because I used variables. Okay, anyway. Let's comment this out for the moment. Let's go back to this for the moment. And let's say there is another depth that we are going to write out here. And I'm going to run new here. And we need -f. So R16, I think, is something that we can do. Not validated for formats. Invalid format given. Interesting. Right? R16F. Right? It's so weird. Because it'll run with BC4, right? Or am I just losing it? Oh, because this is not... Hang on. That's the input. This needs to be the output, FMT. So that runs. If we get rid of this, it doesn't run because we need format, right? Not validated for format. This can't be R16. That seems bad. Terminated by SIG-Sev 11. Well, I think that F is really throwing it for a loop. So R16, same issue, not validated for format, invalid format given. So what actually... We see so many formats here, right? BC, whatever, whatever, whatever. This is all great. ETC2, ATSC, whatever. Why don't these work? Explicit format to build MIPS and for HDR. I guess that's just for MIPS, or if I guess we are LDR, so that doesn't work. Signed, normal. It's not supposed to be R1, is it? That's so, that would be so weird. Okay. Question. This is really... Right. CRAM Vulkan format 139 is the actual BC4 compressed format, which is kind of unfortunate because how do I create that KTX? I don't really want to have to encode it here. So what is actually happening is the real question. R8, G8, B8, UNorm. We're not going to be using encode. We could just drop it, right? We could just drop the data. It's fine. The warning exists. The warning is fine. I don't want to. Number of layers, number of MIP levels. Transfer function. Color primaries. You can do cool things like modify the texture coordinate origin, which is really cool, but not useful to us right now. Convert primaries. Feels very strange. So that's an issue for me. It's not really an issue in general because most people aren't using 2D texture arrays like this. But if CRAM can't take multiple PNGs and turn them into a 2D texture array, and we can't specify it because it doesn't accept the same data in KTX, then that's really weird. I assume that Substance Designer is using a 16-bit format because the data is 16-bit and not for no reason. Right, texture types, 2D array, should work. Oh, the other thing about CramView that's cool is it can show like the texture on something, which is kind of fun. These formats are disabled. BC1 with alpha, BC2. KTX2, KTX. To generate super compressed. Drop MIPS, build 2D array. Yeah, I mean, I get all that. What is KTX2 KTX? Create a KTX2 file from a KTX file. Okay, that doesn't help us. KTX transcode. Let me do a KTX info on the produced other file here. So this is uncompressed depth map, right? So KTX info, assets, processed cram, uncompressed depth map. So we end up with 16-bit. R16 unorm. Three layers, as expected. Only got a red channel. Feels very strange. So do we get any other information here? Quick diff, debug. That's cool. You can just kind of show random grids. Preview. This is like a repeat mode. It's only got the one file here. It's got no MIPS. Or it's got 12 MIPS actually. Something just happened. I hit... yeah, let's not hit that perf button. That perf button crashes something. That didn't help at all. Let's open... Some of these settings seem like they stick. Tangents, yada yada. Looks like a really confusing editor. It is not an editor. It is just a viewer, but it is absolutely confusing. If you don't know what you're doing, all of these things are single letters, and you have to hover over them to figure out what they do. The other option is you can go to the GitHub repo, which should be this tab. If you go to the GitHub repo, there should be this code block. Show keyboard shortcuts. P is toggle preview, G is the grid, D is advanced debug mode, etc., etc. So if you really want to read a little bit about what each of those options does, that is in the README in the GitHub repo for CRAM. But otherwise, I absolutely agree with you. It is a very confusing thing to use. Right now, my issue is that we have a 16-bit PNG. When we feed 16-bit PNG into CRAM, everything works great. It applies the compression, it applies the super compression. We get out a KTX file with that data inside of it. And it works. That file works. The problem is that once we move to 2D texture arrays, we start having issues. Let's comment this out just for kicks for a second. I don't think you can give I multiple times here. I've tried this before. But always worth... Maybe I missed something. Yeah. Unsupported format. VK format 70. How is that still... This is the raw stone, the raw whatevers, right? CRAM and code. We're doing the same thing down here. With the same depth map, assets, raw assets. In this case, it's floor graph. Right? So it just worked? Does it work with two of them? Works with two of them. What is going on there? Work with three of them? Okay, so I don't know why it was still causing an issue. Maybe VS Code is just bad at saving files. And we were still using the old file. So let's open CRAM. And let's make sure that we're using the right file. O target depth map, and that target is processed array CRAM. So let's go file, open, processed array CRAM, depth map, open. And where is the all button? Show all. So I think it's just using the last one. These are empty. I'm so confused as to what happened there. So this is supposed to be showing all 12 Mipmaps in a vertical array. But for some reason, let's just try to do one eye again. I think having multiple inputs messes it up. Or maybe it's just the 2D texture array. Because it's a PNG, therefore it can't access any of the data because it's not a 2D texture array. Maybe that's the issue. I mean, that would make sense. It's really unfortunate. So we have to have a KTX, like I thought, before we send it in here, which is problematic because for some reason the same data that works in the PNG as 16-bit doesn't work when we pass it in via a KTX. So the question here then is, do we need to use KTX to apply BCN? The question being, can it even do that? I feel like it can't. I feel like it's basis. There's BC, target, KTX transcode BC4. I think we're just going to truncate it for the moment, honestly. Right, because R8 unorm works. Right? The thing is just we have 16-bit PNGs, and we're theoretically truncating that data down to 8 bits. So we don't have CRAM open. Let's reopen CRAM. And it should be this one. And this works. More or less. I think these are the right values. The same values that we saw in the original. Right? These are 145, 146. And interiors are like mid-hundreds. That looks like the right data to me. I think these are just 16-bit files for no reason. I think that's the situation. I think Substance Designer is outputting 16-bit files, and we do not have 16-bit data. Because otherwise we would have like 256 or something, right? We wouldn't have 145. And it all looks correct from that perspective. Right? The concrete doesn't have a great depth map because it doesn't really have depth. But that's a different thing. So if we open the original depth map for the single process, right? This is the same one, but processed as a single file instead. And it's got the same values. So I think these warnings are superfluous. I would like... Maybe it does some math and does not want rounding errors. Yeah, it's just weird that we get the base color as 8-bit and we get the depth as 16 and we get the normals as 16. Like, that whole thing is weird. Because then we end up with a 16-bit file that doesn't have 16-bit data. And just to be clear, I don't get the option here, right? These are raw by default, and this is sRGB. But I don't get the option here to specify like 8 or 16-bit PNG. If I click on this, click on this, these are our outputs. Right? The output of this is 8 bits per channel. Right? This is an RGBA merge that creates that metallic roughness. This thing that I'm using to like power these outputs is also 8 bits per channel. So why is the normal map 16? Right? I don't know. It's very confusing. I wish that Substance did a better job of describing what it was actually shipping. So with all that in mind, then we end up with this. Linear 2D array BC5. So does this just work other than these like awful 16-bit warnings? Right? Normal, possible loss of precision. Why is the file 16-bit if all of the inputs and the output is 8? So if we open Cram one more time, Cram V, and we open recent, or not open recent, let's open these one at a time, make sure we're opening the right files. Cram, base color, view all. These are our base colors. Don't they look great? Right? Tiles, grass. All the way down is MIPS. You can see losing resolution. Right? Here are our 4x4 MIPS. This is a BC7 compressed set of files. Let's take a look at the depth map. Here's our depth maps. Same thing. 2D texture array. Here's our normal maps. Our normal maps do look weird, right? This does not look like a normal map. That is intentional because these have been transferred from XYZ normals to a 2-coordinate XY compression. That's why we can use BC5 here. So all of that said, if we just assume that Substance did something weird and we truncate, which looks correct to me, I will say, then we'll undo our circular base. We've got a standard material here. Standard material has an extension. We don't want these to be basis files. I want this to be the processed array cram. Maybe Cram has a secret shortcut to recalculate the third channel. It is doing the 3 to 2 for us. And then Bevy actually does the 2 to 3 back out for us. That normal map, that is the right output for the compression algorithm that we're using. It's supposed to be 2 channels. So processed array cram, right? Processed array cram, depth, base, normal. Here's our base color. This is our normal map. And this is our depth map. So all of this is interesting. Why? Why are we doing this at all? What's the point of having a 2D texture array? Does that look weird? It looks a little weird. We have our lights on. We're doing our loads. Is this RGB false? Normal depth. Base color. This is our array. Did I comment out the lighting? This has a shader on it, so I need to check my own shader logic here. Here's our PBR lighting and everything. Right? I know this is like a lot of windows open at the same time. That looks wrong. Still. Did I mess something up with the... Nope, base color should be sRGB. Why is that not working? Oh, that's because it's not the sampler, it's the settings. Feels weird to get that output. That output is too dark. It's very, very, very dark for what we're trying to do. And that's the color information, right? So let's get rid of the normals and the depth. Oh, right, we can't because I've made them required now. Hang on. Let me get rid of those. Let me get rid of these. This is my own way of sending in these 2D texture arrays while I test the standard material overrides. Right. Okay. Anyway, I've written the shader such that these textures have to be there. I haven't put any if conditions in or anything, so they do have to be there. I can't test not having them at the moment without changing the fragment stuff. This is very weird. This feels wrong. Because if we take the basis file, which I haven't deleted yet, and we run this, the basis file invalid image extension basis because I turned the basis universal features off. Features equals basis universal, which is required to load this file. And it's a bevy feature. So this will compile in some more extra dependencies. It would help view check the texture is okay. Oh, maybe it can do the 2 to 3 in the viewer. Maybe. Let's see. Here's red. Here's green. Tangents, lighting, shape channel, shape, UV preview, fit, reload, perf. MIP. It's weird that these numbers only go up to. So if I don't show them all, I can only see one at a time. Let's see. W is wrap, preview. I don't know how to reset the settings in this application. But you know what I can do? I can reopen it. So the normal map is the one we want to look at. The show all, wrap, preview, grid, debug, quick diff, info. I don't know if it can. I think it only shows what's here. I don't think it shows. Also, checking UI hides it. I don't understand why that's the case. Oh, you know what? Basis loaded and it's the same. Maybe I messed with my lighting. Let's go see what I did wrong. Because I think this is a me issue. I don't think this is a... Did I comment out lighting? Did I break lighting somehow? If I save this file incorrectly, WGSL Analyzer will just break the whole thing, which is great. Let's get rid of the fancy logic for picking the index, and let's go with something that is very straightforward. Let's not sample these. Basically, I've extended the standard material functions to work with texture arrays here. So, very possible that I did something really weird. The color isn't using the 2D texture array at the moment. Where's Cram? Let's open Cram. Let's take a look at the base color quickly. Open, processed, base color. Looks great, right? Looks great. So the issue is in the Bevy app somewhere. Why is the issue in the Bevy app? What did I do? Scooby. sRGB true is the default, I think. But we can set it there just to check. Let's get rid of the basis feature. We don't need it. We're not using basis. The other thing I want to check is if we don't use the texture array and we do use... I feel like I deleted something at some point and forgot about it. Hit the wrong key or something. Dropped my face on the keyboard, you know? See, this looks fine. So it's only the 2D texture array. It's only the material extension because this is also a compressed KTX file and it looks fine. It has all the lighting, does everything perfectly. So it's a me issue and it has something to do with the way that I messed with my shader, I think. And if I do something silly like this, and I make sure that I am not using the thing that doesn't use the... Okay, there we go. Circle. All our textures are in. Run. This is the 2D texture array. What is the problem there? That is so weird. Let's do... See, that's red. That's red and that's bypassing everything that I did. So what is the issue? Did I delete something and forget that I deleted it? That's not good. It would be really bad if it was in this file. This file is 1,000 lines long. Did I comment out something? I don't see anything commented out. Nothing that isn't supposed to be anyway. See, that's just supposed to be red at this point. Right? Layered. Red. Base color. I'm going to bypass everything just to do a check. Debugging shader is always a dark art. I'm not sure here. Okay. It is something to do with the lighting. Oh, did I just remember something? If def standard material normal map doesn't get set because we're skipping the standard material stuff. So also flags, double-sided flags, depth map bit. Here's one. The depth map is always set. So that does need to be like that. Basically, using these, I'm bypassing the standard material textures being set is one of the things that's happening here. And by bypassing, I'm still calling the PBR input stuff, but I have if. Where's the matching curly brace here? Who knows? Are there any other curly braces? No, it's got to be this one. Okay, let's go back to layer. Let's get rid of this color. That color looks so off, and I don't know why. There's got to be something else. Let's look for more standard material, base color UV, alpha mode, alpha to coverage, unlit, specular tint. What do we have? We have base color, we have normal, and we have depth. All of which I think are... We did almost have metallic roughness, so we would need to go set that. Did I change something in here? I did get rid of the PBR layered materials flag. I don't think that matters. Actually, if I turn that on, I think I break my texture bind limit. So I can't turn it on. Big What is going on here? Why are these images not... They don't have the right color. It looks like they're unlit. Standard material, asset server, base color texture, normal map, blah, blah. Standard material, right? Let me take a look at the material extension and compare my code to like a default standard material extension. See if I deleted some. Let's do the 17 branch. Assets. Shaders, custom material extension. And this does the PBR input. It does an arbitrary flip of like setting R to B, alpha discard, deferred, lighting, main pass, color. Nothing here. So let me revert this and see if the issue is this function. Yeah, that looks like the issue is the function. Are you sure this is a shading issue? Maybe it's something related to the format or color space or 16 to 8-bit conversion. I'm not sure it's a shading issue. We are just truncating the 16-bit. The numbers did look correct when we checked them, right? It's also, the truncation is not happening on the color texture. Is the other thing I'll note. Right? The truncation is only happening on depth, and it's only happening on normals. It's not actually happening on the color. I don't think there's anything else that we would need to set here. Right? Is sRGB, texture format, sampler, render asset usages. All this should be set just fine. When we look at it in CRAM, it's fine, right? File, open, process array, CRAM, base color. This looks great. So if that looks great and the single version of it works, then it's got to be something I did in here. So let me take this, do that, set this, and see what happens. See, even that looks very much different. Right? Like, this looks far more reasonable. I think I messed up the lighting calculations in the forked PBR input from standard material function. I think I deleted something. Which just means I need to rebuild that file because I'm not walking through 1,000 lines of code to debug it. I'm going to take that file, I'm going to copy it over again, and I'm going to do the modifications again. I should have committed it before I made the changes, and then I would be able to git diff it, but I can't because I didn't. Oh, live stream, nice. Hey, Galaxy. Sorry, I need a little bit of water. What time is it? Almost 11. Give me a second to fill my water bottle up, and I'll be right back. And we'll go for a little bit more. I've been dragging myself through texture compression stuff today. Okay. Current issue. Current issue is that we have this. Which is fine. This is a manual sample of the base color texture. And it's using the original PBR from standard material. If we change that import, give it the arguments it needs, then it doesn't work. But we're still overriding the base color here. So that's really strange, right? 0 to 17 right now. This is in the Bevy examples repo. So it's all 0 to 17. You've been trying to create a basic custom fragment shader for 16. It's going slow. What's going slow about it? What are you trying to do? There is the shader example for the material, custom material inside of the Bevy repo. That's the first place I point everybody. What's the issue here? You want to set an alpha F32 from 1 to 0, and it's just making the image disappear immediately when you set the mesh material 3D? Did you set the alpha mode to blend? Yeah. So it hears immediately. If you have access to the fragment shader and you're setting in, if you have access to the fragment shader and you're sending data in, and it's going to be 0 to 1 data, you can output that in like the red channel of the texture. And that should give you some information. Sorry, I'm starting to lose my voice. Okay. Big question is, why? No, you're good. Questions and issues are always good. So we have all of our samplers, etc. We have everything. Base color. Here. I set this to if true. I absolutely messed something up, and I don't know what it is. I might need to... We'll call this a backup. PBR input from. Define a uniform. They don't need to define a uniform separately these days. I mean, you can, but the standard material defines a separate uniform. Where is it? Are you in 2D or 3D? I didn't check. It doesn't matter. 3D. Custom material. Blah, blah, blah. Why am I shader material? I don't know why we call the shader custom material and the example shader material. These should have the same name. Yeah, you're using a plain 3D. Cool. So you have then this and this already set. Like, I assume that you basically straight up copied this for the moment. Because this already has everything that you need in it. Right, like it doesn't matter if you want an F32 here or whatever, you can just use the linear RGBA for now. Oh, yeah, that's why it doesn't work. Why are you even using that? That doesn't make any sense. There's literally a working example right here that does what you want. All right, well, back to the other stuff. I'm not going to debug slop. Okay, PBR input from standard material. Here's the function. That's deferred. Hang on, we don't want deferred. PBR functions, right? No, it's PBR fragment. So this is the whole file. So we'll copy this. I need to turn off WGSL Analyzer, actually. Come on, VS Code. What are you doing? Why does it say restart? I need to turn the formatting off. Experimental preview. Niche's offset size. Fill default fuel format. I just want this off. Okay, well, I guess I'll disable WGSL Analyzer for the moment. Well, we need it off because this format situation, like when I save it like that, it breaks. It especially breaks here, right? PBR bindings, comma, colon, colon, space, and that'll be a silent failure. Yeah, it would be a lot faster actually if you didn't use AI, considering there's an example that does already what you want that you could have looked at. Yeah, the hot reloading for assets is really nice, for sure. Okay, well, I can just try to remember to not do that. I feel like okay, we're going to define the new import path. This is going to be our override. It's the first thing we need to do. So far, so good. Let's pull layered here as well so we can go back and forth a little bit. We unfortunately can't do we can't do hot reload for shaders that are inside of Bevy, which is kind of the way that we're using this right now. So we're going to have to rerun this a couple of times. Cool, invalid function is great. That's what we want to see because this is an invalid call to that function. Okay, this is our default state. This is what it more or less should look like. This is unfortunately only the color sampled separately, laid over the texture. So there's work to do. And specifically, we need to start with passing in some of these arguments. So these are the arguments. The array index, the color textures that we're going to use. This is a really unfortunate syntax highlighting situation that I hope gets rectified within the next 6 months. Where's our actual function? PBR input, line 82. So it'll be here. We're just going to add these arguments. And then we're going to go back to layered and we're just going to enable these arguments. Step 1. Run it. It looks fine. Continue a little bit more. Now this is if we get rid of that texture, just a white surface. So where are we? We are in meshlet stuff. The very first thing we need to modify, I believe, is the base color application. So we called this index, right? In our arguments, array index. So here's array index 174. 174 is interestingly not the same this flag here on 148 is not going to get set. That's so interesting that this is so far below. Okay. Let's get this comment in here as well. Because looking at these with the same line numbers is going to be super useful. So PBR input from standard material. We have effectively forked it. Now we're modifying it to use our samplers and the passed in values instead of the global bindings. So the first place that happens is inside of vertex tangents. Right, so here we've got vertex tangents. We've got if flags and standard material flags depth map bit. I think that probably the thing that I want to do is set these flags and specialize. That's probably the real answer here. So what are these called outside of this? Because we don't actually want to look at the WGSL at the moment. I want to look at the flags. This is WGSL. Let's look for... Why is this not giving me the ability to do a language search? Oh, maybe there's not enough results. It's all WGSL anyway. Standard material flags. Let's just do standard material flags. Here are the flags. This is what we're looking for. This is as bind group shader type. But really, I want to see this in a specialized function. Which I think something has this in a specialized function. Yada yada. Standard material uniform, flags bits. Can we not actually do that? I thought we could. Is specialized function just a function you can call in a shader? Do you mean the thing that I was just saying, the specialized function? The specialized function is a material concept. So if we go to the material trait, right? Like obviously there's fragment shader. You've already used fragment shader. But on the left-hand side, there's a couple of different functions. Alpha mode, fragment shader, specialize. Specialize is the one that we care about. Or the one that we're talking about anyway. So if we go to the shader example that we were looking at earlier. Shader material. I guess we don't actually use one here. But you see how fragment shader is here and alpha mode is here? This could also have specialized. One of these examples has a specialized that I'm going to point out. None of these have specialized on them. Right? Only when I want to talk about specialized can I not find a specialized. Okay, here we go. This is a custom phase item. That's not probably what you want. Here's a material 2D for a custom material. Here's a specialized function. When you implement material or material 2D or extended material or whatever, you get this function as a thing that you can define, right? It gets passed in the render pipeline descriptor, the mesh vertex buffer layout reference, a couple of other things. So actually, I think that the key is something that we can use here. So do we have... Question. The extended material should have a specialized function that has that key. Basically, deeper in the rendering APIs, so at like a lower level than material, all of these things get configured and set. And the specialized function on your material gets called at some point in that cycle so that you can make changes if you want to. If you weren't using standard material, that would be the place where you could set cull mode. That would be the place where you could set double-sided, things like that. It's just a function that gets called. You get a bunch of data that you can then modify, and it affects how your thing renders. Where's our material extension? Extend. Extended material. I always forget what it's called. So a material extension, specialized function, has this function signature. If we go to main, and I go to my material extension, actually, I could just implement default members like this because Rust Analyzer will just do that for me. And now I have this function called specialize, and I believe that the flags are actually on this key. But I haven't done this in a while. So that's an open question, actually. It's the mesh pipeline key. I want to be able to set the standard material flags. And I feel like I've seen this done before. G-band dither. None of these are the standard material things. So maybe we actually can't. Maybe that wasn't true. I feel like the material extension should be able to set that stuff. Maybe I was doing this when I did more copy pasting of the standard material. But you get access to a whole bunch of other stuff. One of the things you get access to in this specialized function is like vertex state and fragment state. So if you wanted to set a shader def inside of the fragment state, you could do that. If you wanted to have, or if you had like a custom vertex attribute, you could come in here and add shader defs to say that, hey, we should process this if it's available. There's examples for that in the Bevy examples. Yeah, I mean, like you get to modify any of this basically. On the primitive state is where you'll find cull mode. Most of this stuff you really don't want to change, especially if you don't know what you're doing. But it can be fun to play around with. I think the things that I use it the most for at this point are custom vertex attribute data. But this specialized function, it's not like special. It's effectively the same thing as if you had a trait and your trait was like, hey, do something with this number, or like specialize this number. And Bevy was like, great, here's a 0, specialize this number. And you were like, great, I'm going to add 2 to it. And then that gets passed back to Bevy, which then calls other specialized functions as well. And maybe they add 1 or they add 2. And you end up with like the number 5 that comes into the pipeline. It's the same concept, except you're doing it with render pipeline descriptors and vertex state and fragment state and things like that. Everybody gets an opportunity to modify things to make sure that the rendering pipeline does what it needs to do so that your shaders can run. But there's nothing inherently special about it. Okay, so the question then is, can we even set those flags? For the most part, you don't need to use specialize. But when you need it, it's very useful. Okay. I think I would have preferred to set these flags rather than modifying the code, but I can't think of an easy way to do that. So instead of setting these bits, I'm going to replace these with if true. Right? Standard material flags depth map bit. We have a depth map. It is going to be the one we pass in. Unfortunately, this is probably the most complicated change that we're going to make. This is also the backup. It's not the one I actually need to make the change in. So let's go back over to PBR fragment. We will say if true, do all of this stuff. So we are doing all of this stuff because it's true. And then we need to pass in both the array index, the depth map, and the depth map sampler. Right? Parallax to UV is now a function that will accept these. And it will get called every time. So what that also means is that if we have different UVs, we also need to set that if we call it for the other UVs as well. Trying to make things, generally speaking, work by default. So base color texture bit, same thing. This needs to be if true because it will exist no matter what. This array index. So one of the things that happens here, right, is if you're operating on different kinds of textures, different functions are overloaded to accept different arguments. So if you go to the WGSL spec and you look for something like, what are we using here? We're using texture sample bias. So that happens to be texture sample bias. Doesn't matter what texture sample bias does. It's basically the same as texture sample. But if I make this a little bit bigger so people can maybe actually read it, this is all of the ways that you can call texture sample bias. So if you have a texture 2D, which is just like, you know, a PNG or something, and a sampler and some coordinates, then you can pass in those things with the bias and you get back a color, right? Because you're sampling the texture. If you have something like a texture 2D array, there are actually two ways you can call this, right? You can call it with the texture 2D array, the sampler, the coordinates, the array index, so the texture array index and the bias, or all of that plus an offset. The array index for us, we have 3 images in our texture 2D texture array. So really, this is the way we're going to call it. We're going to pass in the texture 2D array, the sampler, the coordinates, etc. So this is a little bit of if-def soup, right? Texture sample bias and texture sample grad are 2 different ways to do a similar thing. If this is a mesh material pass, because there's a lot of logic stuffed into the standard material. If this is a mesh material pass, it'll use texture sample grad. If not, it'll use texture sample bias. So then this is the first and second argument to that function. We won't have bindless enabled here. So we actually end up with just these 2. Basically what I'm going to do here is take away that import. So instead of referencing the import, it's going to reference the argument that we passed to the function. And then the UVs are the next argument. So one of these will get passed in. And we need to add, so we've got our bias here, our MIP bias, right? And right before that, we need to add the index, because that's where the argument goes. So if true, run the sample bias with the index that we've chosen to select for this. And then we move on to the next one. This isn't unlit. Although now that I'm thinking about it, no, this is not unlit or anything. Specular textures. If we ever want a specular texture, we'll have to come back and do this as well. Emissive textures, same thing. Roughness. We've already done part of depth and we've done the actual base color here. So we actually need to do the normals. So here, there are some normal calculations. And then we get a normal map texture, normal map sampler, the array index. So what is this? This is 723. So let's go for normal here, right? I don't think there's an if around this. If load normals, or if not load normals, do this. Right, if def standard material normal map. So basically this is always going to be true. So we're going to comment this out. We need to add our array index to the same spot for that function, depending on which one we want to call. Great, everything there should be good. Apply normal mapping should, because it comes from PBR functions, just work. We can go check. Let's go check apply normal mapping. PBR functions. Where's PBR functions? There it is. Here's apply normal mapping. It takes the flags. So the thing we need to check here is the flags. This says standard material flags to component normal map. So that brings up an interesting question. How does this actually get set? I know we've looked at this previously. I think if I remember correctly, it samples the normal map and sets this based on how it samples that normal map. So I think actually we need to copy and paste this function and call our own where that is always enabled. Which is unfortunate. I would prefer to be able to set this flag. But I can't think of a way to access the uniform for the standard material. And I think two component normal map. Let's go with two components. All right, that's WGSL. This is PBR material. Here's where it gets set. Flags, two component normal map based on the texture format of the normal map, but we're not passing the normal map into the standard material. So one thing we could do instead is pass in the textures that we're using as single textures, but that's not going to work for us because we're not going to have that texture. I still feel like we should be able to access these flags. I'm going to look for it one more time. I think I feel like that because I've copied and pasted large swaths of the standard material in the past before we had an extended material, and thus was able to modify that in Specialize. Does decals set anything like that? Depth stencil, compare always, fragment descriptor. So this is an example of setting a shader def. If you are interested in like what that would look like. This is basically like a binary flag in the shader. So when it compiles, this will either be true or false, and you can do things based on whether it's true or false, or include different code based on whether it's true or false. So this is the specialized function for the forward decal in this case, which is actually an extension, a material extension. You think you remember it in as bind group and not specialized? Really? I might be misremembering. It's been a while. It just sits in the back of my head. As bind group shader type. Material, debug flags, specialize. These are internal pipelines. Prepass might have it. We don't have access to properties here, do we? I don't think we get it. I don't think we can get access to. This is the mesh pipeline key. I don't think we can get it in the layout. I don't think we can get it in the pipeline. I swear I remember doing this though. It's absolutely getting to the end of my day. I've been up. I've been a night owl lately. That's just the pipeline. It's not in the descriptor. Wouldn't be in the layout. Right, mesh vertex buffer layout, that's not what we're looking for. In any case, I swear this is possible. So you can call specialize on that pipeline. See, self.properties.bindless, shader defs push bindless. They're calling specialize with the material pipeline descriptor, layout, and a key. Flags for system, flags. All right, this is where it does the magic. For flags, shader def in. Maybe we just do this. Because they all turn into shader defs at the end of the day. Maybe instead of futzing with it, we just set them. I like that actually a lot more. Than setting them all to true in the code. I want to make fewer code changes. I want to make more configuration changes. So let's do what? Standard material normal map. Specular normal map UVB. What are the others? Here are the shader defs for the fragment shader. We need this little if condition, because if we don't have this little if condition, then we aren't setting them in the right spot. So if we have a fragment shader set, then we will go into the fragment shader and get the shader defs. And what we're going to do at the end of the day if key bind group intersects flags intersects. Oh, that's just checking for the flags in the bind group data? That's really... I've actually never seen that. Because that would be key dot bind group data dot intersects? I've never seen that used like that. Key dot bind group data dot intersects flags. What is the bind group data here? Material pipeline key. Well, it doesn't matter. We are going to set stuff. For, let's say, shader def in, and we are going to just start setting the ones that we want like this. This is our specialized for our layered extension now. It's not perfect. This won't really extend necessarily to other users, but we're still kind of in the prove it works phase in the first place. So let's check for our if trues. Let's get rid of the regex here. If true. Right, because we don't want if true, we want standard material depth flags bit. That's not a shader def, is it? What is that? PBR types. PBR types, render, PBR types. It's a constant. That's a bitwise and, isn't it? Dang. So it would need to actually be passed in. I don't like that. I don't like that much. In any case, just makes it a little bit harder on us. So the normal map then is a constant. So we can set that. So we don't have to undo this if. But the other things aren't going to be, actually. Because standard material depth and base color texture bit are both flags, so we just have to set them to true in the code. It's unfortunate, I think, but okay. So let's do... We have already done standard material depth and color. Where's what were we doing with the normals? We were trying to set them again, right? We went to look at whether the normals were going to be able to be futzed with. So this is again a bitwise and here. So if we want this to be, if we want this to work, we have to be able to pass this in somehow. So we have to fork this function. So let's get this all the way down here. Let's get this link because I'm taking it at this specific moment in time. And if you've ever worked on something that you're doing like this, it can be very useful to know when you did something. So this is going to be true. And I'm leaving everything as if true because it makes it easier for me to find and replace, or find and like know where I modified. Because if I search for it like true in parens, nobody's going to write that code. That's not reasonable code to write. So for all of our stuff, the 2 component normal maps have to be applied. That has to be a thing that exists. We might be able to change that. I'm actually going to fork, like, hard fork is the wrong word. I'm actually going to take a lot of this code and package it up into a different crate so that I have a layered material that works with texture arrays. And when I do that, some of these things are things that I will replace with my own shader defs or my own detection to make this easier, just in case somebody doesn't want to use 2 component normal maps. But we'll see. We'll see when that happens. So this apply normal mapping is here and there. Clear coat and clear coat. I don't think clear coat ever gets called for us. We don't have a clear coat in general. The question here, this is all data. This doesn't do any sampling. So the only thing we needed to do was make sure that that branch always applied. And now we'll get yeah, okay. Now we'll get just the normal map here. So the normal map will just work. This shader def is going to be set. The normals will come from the not two's complement, from the 2 components instead of the 3. And then we have one more thing to do, and that is the parallax UV function. So the parallax UV function is another one that I overrode. I think it's actually it's not in this file, is it? This is sample depth map. Yes. Okay. Everything from here down comes from a different file. This is, which file was this? We do a search for it. Parallax mapping.wgsl. Who would have guessed? So I'm going to copy this raw file. This is not going to be brought into scope. This is going to be just thrown at the bottom of this file. Again, this is kind of prototype-y level code, so I'm not too worried about it. How often do you do these shader streams? You'd love to catch these more often. This shader stream is a little bit more in-depth than usual. I usually don't dig into the standard material and start forking code from internal Bevy stuff. But Saturday morning is my Bevy related stream. And we do shader work those days fairly often, I would say. Typically the shader work that we do is much more accessible, is what I would say. What we're doing here right now is very, very in the weeds and very probably not something that everybody else is going to run away and do. Is the way that I would frame it. Less invasive. Less invasive is a great framing. Typically the work we do is less invasive. This is very invasive. I'm trying to patch texture 2D arrays into the standard material in a way that is not particularly easy to do, I guess. Okay, so sample depth map has to take a couple of these things. So we aren't going to accept the bindings for the depth map because we're going to pass those in, right? And here, sample depth map then has to accept more arguments. Right? Sample depth map has to accept these arguments because these samplings have to be those arguments. And we will pass in the array index as well. Now the root function that causes this to happen is parallaxed UV, which also needs more arguments. See, this is sample depth map in here, so sample depth map is going to need these extra arguments. I'm going to put these on a new line. I think this goes back one. Just go forward one. And then there's one more sample depth map in here, two more sample depth map in here. So we'll just continue the pattern. There's a couple of different ways you can do parallax depth. You can do relief mapping. You can do a couple of approaches. Okay, I think this is good. It's a little bit awkward with that subtraction sign. So I think I'm just gonna raise this to the previous level so that it looks intentional and not like an accident. Okay, so we've done all the work that I think that we need to do. So with any luck, we run this. Okay, I didn't remove the parallax import. Parallax. So this needs to get commented out. And we're going to run this. And the array index can't convert elements of I32 to F32 at PBR fragment 1. Obviously 1 is not the right spot. Am I calling this? No, I'm not calling this as an F32. Why does it want this to be? I think this is an F32. Let's get this bigger. So a value with elements of type F32 is required here, which is nowhere. There's nowhere. There. This expression has type I32. Automatic conversions cannot convert elements of I32 to F32. Okay. So the question is, this is an I32, but why does it think we want it to be an F32? Did I put it in any of the wrong places? Texture sample level. Nope, that looks right. This is also I-32. This is also I-32. The only other thing that I could think of is that something is weird here. So let's say let index equals 0. Automatic conversions cannot convert elements of I-32 to F-32. Why does it want it to be an F-32? I think there's a syntax error. Did I mess up removing any of these? Don't think so. Is front in is front index, then all of these things. Why? This does the same, right? Why does it think this should be an F-32? Slot, array index. This is why I kept the differences. Okay, why? What's going on here? Array. I-32, array index, sample depth map. Sample depth map. Light maps. Okay, let me try one thing. PBR fragment dot new. Replace this with .wgsl. Run. Hope we get the same issue. We got the same issue. That's a good thing. Why that thinks it needs to be an F-32, I don't know. Fragment index. Maybe change the function argument type to F-32 for a second and throw an error. I could try it. I think a different error will pop up. This is one of the unfortunate things about the current state of shaders, is that this error is like clearly trying to point to something, but is trying to point to something that like got compiled in. A value with elements of F-32 is required here. So theoretically, I could just make this an F-32, right? And then we run this. and we get the same issue. So I'm pretty convinced that the issue isn't in that file. So is it over here? Yeah, very odd. Very odd for sure. PBR input. Okay. That's good. Why would this be happening? Where else do we use index? Nowhere. Hard code 0 into that function. With all the if-defs, the multiple files of renaming and unscrambled, yeah, I hear you. I hear you. I hope we get rid of the if-defs, or at least, if not get rid of them, make them easier to manage with when we move to Weasel. Because it's not a great situation. The if-def stuff scrambles my brain as well. It's definitely serviceable, like it works. Don't get me wrong. Automatic conversions cannot convert elements of I32 to F32. I32 to F32. Where would this need to be in F32? Original UV. Texture sample level. Do I have an F32 sitting around here? Nope. Very confused. Weasel will at least fix this non-meaningful error message? Yes, I believe it will. Weasel supports input. No need for processing magic to do it. Yes, absolutely. It also supports a syntax version of like if. That should work better with a language server. I'm very, very, very excited for Weasel, assuming it actually lands. Okay, sample depth map. UV, material bind slot. UV, material bind slot. Returns an F32. Fine. Why? Regarding the error message, isn't there a way to output it with the imports expanded? If you know of a way to do that, let me know. If you know of a way to do that, let me know. I am not aware of that. Texture sample bias. MIP bias. MIP bias is always last for texture sample bias, right? What else do I have in the... There's also a 1,000 line WGSL file. PBR fragment, bindless filters, PBR functions, bindings, types, prepass, light map. What in this 1,000 lines has an issue? Feels weird. Let me read the error message again. This expression has type I32. Yes, it is the argument to that function. A value with elements of type F32 is required here, allegedly at line 1-1. And it says automatic conversions cannot convert I32 to F32. Do these arguments, am I wrong? Am I wrong? Array index A. A is I32 or U32. Good. That's what I expect it to be. Is that ever F32? I don't think it can be. I don't think I'm trying to use array index as an F32 somewhere. I really don't. I've checked that 3 times now, actually. Because it's very possible that I did do something like that. But I don't think I did. You think I have bind lists potentially? I think the only way is that those get called. You think texture sample grad would be it for meshlets. So bind lists would be here. Bind list, bind list. That's transmission textures shouldn't be running. Transmission textures. Occlusion texture, we don't have one of those. Standard material normal map. NT equals sample bias. If bindless, array bias. Also, maybe we forgot to modify the code to pass the array instead of the texture. We did. Look at this. Right here. Normal map. I think that might have been it. That's it. That was the problem. Did I also do that here? No, I didn't. But it must be somewhere else. Material array. Don't know. Can you explain the issue? So, PBR bindings is an import from another WGSL file, right? The import syntax Bevy uses is custom. And there's a whole chain of tooling under it with Naga oil and stuff. The normal map texture by default is a texture 2D. right? So if it's a texture 2D and I didn't remove these, right? We do want to remove them, so I'm going to save this. But if we look at this texture sample bias docs, right? Texture sample bias, and we look for texture 2D, the arguments are texture, sampler, coordinates, bias, right? And for texture 2D array, it's texture, sampler, coordinates, array, bias. But also note that there could be a second version of texture 2D with the same number of arguments. So texture, sampler, coords, bias, offset, not array index, right? Fourth becomes an F32, whereas the fourth here is an I32. So it was the overloading of the function. The fact that functions can be called with different kinds of arguments and different numbers of arguments with the same names, that's what we were running into. The fourth argument here was the array index because we were intending to use this version. But we actually got this version because I forgot to switch out the texture 2D array for the texture 2D. So it thought the array index that I was passing in, which needs to be an I32 or a U32, was actually a bias, which is an F32. This is definitely a fuck gun. Okay, you were passing the texture 2D, hitting the other function, and now you are passing the texture 2D array. Yes. I accidentally was still passing the texture 2D, so the definition of the function, like the arguments, didn't change. And thus we fell into this case. Or not this case, sorry, this case. And thus the fourth argument is supposed to be an F32, not an I32. So, all in all, you know, kind of a foot gun. Would have been nice to have a better error message. I think the error message there was pretty bad. It did give the right indication. But yeah, this is kind of par for the course for functions that have multiple implementations like that. So, going back to this, let's get, because we'll be doing our work in the actual file now. Let's put this here. So this is looking significantly better. I don't know what I did to the file earlier. I don't know why we needed to go through this process. Worth noting that. What I think it was that WGSL Analyzer lately, when I save, has been formatting code in ways that break. And in ways that break silently. So I think that's what happened. I think I saved it, it auto-formatted into a way that broke and didn't break in an obvious way. That's it. That's what I think happened. Redefinition of index? Oh, right. I have an extra one down here. Okay. This is particularly interesting. because I think this is a parallax issue. There's some issue in the coordinates here, but I think that's parallax. It's very interesting. But yes, probably just an unnoticed change. That's a bummer. Git commit now. I'm past. If I was going to git commit, I should have git committed when I did the original file. I will actually have to go back and do this again because I didn't commit the original file, and thus I don't have the change diff. So there's something wrong with the coordinates. Or the parallax. Right? It's offset. But overall, the color's back, which I'm very happy about. The depth map texture, depth map sampler. It looks perfect. Ship it, early access. A diff without git between the new and the backup file would probably output a line that is cause. Let's give it a try. I'm cool with that. That's a thing we can do. Absolutely. I always forget how to git diff. Well, no index is the way to do it. So assets. What is it? I think it's backup to fragment. So the depth map is now being calculated. I guess it's the same in both. In one of them, I just commented both things out, and in one of them, I put if true, so those both should be running. Force set the base color texture bit. Use SSAO to estimate the specular occlusion. We're using the new apply normal mapping now. Could be something wrong with the normal mapping. And this is all of our parallax stuff, which is net new. So not sure which thing the culprit is. Might just need to this is always running now. I don't think this is a normal map issue. I think this is a depth issue. Parallax UV. right? Parallaxed UV. So, parallaxed UV gets the array index, depth map, depth sampler, as expected. If def vertex tangents, if UV is A. Is that not happening? Array index, same stuff. Sampler index. I didn't change the logic here for the most part. Let's go back to using this. So it's only when we select a different texture for the area based on the height. Right? So it's only in this case. And this case is something that I wrote. So I'm tempted to say this is just my fault. If it is, zero, 1, 2. If we're less than 2, 5, we do the tile texture. If we're greater than that, greater than 0.75, we do the grass texture. Otherwise, we sample to depths. So this depth sampling up here is not necessary, actually. We sample the 2 depths, we do some checks, and then we specify which one needs to render where. So is the intent that because we're rendering this over that it needs to use the other parallax? Hey Sean, how's it going? Deep shader splunking. Diff U also works. Oh. Classic. Who wrote this code later? Oh, it was me. You use diff directly, not git diff. Okay, yeah. I don't do diffs between non-git files all that often, so I always forget. So the question is, we've basically forked a bunch of standard material shader code from the Bevy standard material. We have done compression on a number of texture array 2Ds, including base color, normal, and depth. The normals are being compressed into 2 channels and being re-expanded in the shader. Depth is 1 channel. So we're using BC7 for the color, we're using BC5 for the normal, and we're using BC4 for the depth. To do that, I had to fork some of the helper functions for the standard material for Bevy so that they would accept texture array 2Ds instead of the individual samplers and stuff. What does the if statement do on 86? 86 is here. So if the X value for the layer 0 sample is greater than the layer 1 sample and the X UV coordinate is less than the X value from the sample, render it. So basically, this is a really silly and cheap way to say from this location to this location, render one texture or the other based on the height of the depth map. I say really easy and cheap because this is the texture array 2D test project. There's a different test project that is actually a triplanar mapped, height lerped, vertex attribute driven transition for these textures. So those two things are going to come together, and we're going to be able to basically paint vertex colors onto geometry in Blender. And the transitions will look a little bit like this. The grass should be in the same, the right place in the grout, right, instead. But that's the idea anyway. We've made a lot. I've made a lot of progress towards it. I have all of the really hard parts done. So now it's just a matter of finding the time to piece everything together and getting the textures and stuff that I want to use. So that makes this a little awkward because what is this? I feel like this has to be parallax related. I just changed the parallax and they moved. So the question is then, if we're doing this depth change and we're using parallax for the depth, then I guess one of them has to be considered the base layer, and we have to use the parallax from that base layer for the area that we're painting the second texture onto. Because otherwise they won't be in the same place. That sounds like what it is going on here. So if to test that, we can actually probably just disable parallax entirely. 0. Yeah, it is entirely the parallax. So the question here is basically, if we're going to layer one texture on top of the other, and we're going to use height information to do it, and that height information is also being used for the parallax effect, then to put this grass into the low grout areas, the parallax either has to be 0, which layers everything in the right spot, or it has to use the underlying, the thing it's laying onto's parallax for those UV coordinates, or it won't be in the right spot. I think. That's my current hypothesis. Right? Because even a small change, so the default is 0.1. 0.1 is pretty big for what we have going on here. And that just throws it into a semi-random spot, it feels like. So something really small like 001. Right, like the parallax mapping for the two textures is going to be different. So I think we have to have a concept of which one is on top of which one, or some way of merging the parallax effect. I think in this case, it has to be the tile drives the effect as long as the influence is mostly supposed to be tile. Does it get closer or further from correct in the distance? Let's find out. I think we would need more. It looks further. It's hard to say though. Like here is almost exactly on, right? The second horizontal line. And then it gets further and further and further. And it looks like it's getting further and further away as you get further away. But it's also getting further away the closer we get to the camera. Looks about the same, you think? I think it is getting further the further the camera goes. Because if you look at this spot specifically, right? This is a white tile. Let's zoom this. So if we look at this, you can see that the grout is here, the tile is here, and the grass is here. Right? That is very clearly showing front of tile. That is not grout. And if you look at the closest line, that is, I feel like, only grout. Right? Because you can see a little bit start to peek through on the second and a little bit more on the red tiles that are a little bit up and then more. So I think it is getting worse in the distance. I think my current hypothesis is that to make the grass look like it's going to lay in the right spot, if we're going to use the parallax effect, because the parallax moves things around, we would have to use the parallax of the underlying texture, or find some way, some algorithm I'm unaware of, to merge those things in the right way. Yeah. We'll see. I don't know. I don't know what the actual real answer is going to be yet. But I am generally speaking happy with this. It may turn out that we just end up using the depth for. Let's do one more thing. I want to make this really, really big. Circle 100. It's a cube in the grout. That's cool. Yeah, this is overall supposed to be a semi-automated like material transition layering solution. The reason, at the end of the day, the reason is because I was working on a replication of Tunic for the skiing demo. And things like this. Is this going to be a full show the image? Let's show the image here. It's going to be really small. And things like this, where there's grass and there's tile. And I know for a fact that the Tunic person used something along the lines of vertex colors to do the translation between these two things. I don't know what their implementation actually was. They used Unreal, or not Unreal, they used Unity's Pro Builder to do a lot of the level design. And there is a lot of things in here, like this tile here that is stuck up will actually be like its own full geometry. Like they just lay patchwork of actual geometry into the scene as well. But the transitions in the world textures were really interesting to me. So I started pursuing that and started on this whole thing. Because like these areas down here, right? These areas that are kind of like noise-based transitions from that sandy area to that green area, from the brick to the grass. I want to be able to do stuff like that. So there's another thing that has to happen here, which is layer noise over it so that the actual transition isn't harsh. The transition right now in this example specifically is harsh. Right? You can't see it as much right now. Let me change the UV scale here. Affine to from sort of new. From translation. From scale. Do we have a scale? From scale. I think this should work. It might not. What is this supposed to be? A Vec2? Vec2 splat 0.1. Yeah, pretty clear clamping going on in that transition. Yes, absolutely. Absolutely. I think we might not be accounting for this currently. Do I have this backwards? Does it need to go higher to go smaller? Yes. So there's some ways in which we need to the PBR input function doesn't do a good job of returning you the UVs that you need to use if you're doing textures like this. So you can see here that there's a clear issue with where the grass is compared to where the tiles are, because the UV scale is only getting applied in certain places. Is that our immediate fault? Where's PBR input? This is on the UVs. Yes, it is our fault. Because the way that we're doing the detection for whether this should be is a little bit awkward, because the calculation actually happens in the PBR input from standard material function to figure out what the UVs should be with that scale. But we have pulled out the decision about which thing to use to before that function. So if we were going to do a scale accurate situation here, we would have to pull that calculation out and do that UV calculation ahead of time. Which we can totally do. It's a very simple calculation, actually. Is it in the standard material one? I think it is. So if we just go into our little thing here and we check for UV, right, we get UV transform here. This is bindless, but it's not important. So UV transform, this is a little, this is a piece of code I wrote to get the UV transform back out of the PBR input. But there's also the issue of this doesn't happen. Like you never get this back. So this and this combined are required to set what the UVs actually are. Something like this. Do we have PBR bindings in here? No, we don't. Let's pull PBR bindings in. Bevy PBR bindings. So we have the PBR bindings, UV transform, and then we wouldn't use in.uv here. We would just use UV. And I think this actually solves the problem. I didn't think too hard about that, so don't be too surprised if it doesn't, but so given this math, let's make this like 0.05 and 0.075, which are ridiculous numbers, but we want to see the transition if we can. Looks cool on the grass though. I know this is not the behavior I wanted, but it looks cool on the grass, okay? Just enjoy the fact that it looks cool on the grass for a second. Okay, so the UV, the issue here, in.uv1xy, UV transform is the actual calculation, and then we get the UVs, the uv.x. This is also not the way we're going to do this in the actual implementation, by the way. It's worth noting that. The way we're doing this in the actual implementation is world space coordinates, because it's a triplanar mapped texturing solution. So we actually aren't going to use these UVs like this. You've decided to touch grass finally. Shit. Oh, I walked right into that one. I think that I don't know what these UV coordinates are anymore. And thus this calculation might always be true. And thus we are always getting grass. One of these calculations is always true. Anyway, something like that. I would need to play with it a little bit to figure it out. But this UV transform thing is something that I've run into a couple of different times, where the PBR input actually calculates this UV transform to modify the UVs, and then doesn't give you those UVs to do anything with. So if you end up having a standard material with some actual textures passed into it, and a material extension that has an additional texture, maybe like noise or something that you want to apply. If the UV transform is used in the standard material, you have to then copy this calculation out and apply it before you can actually get the correct UVs to apply the noise that you wanted to apply. But yeah, anyway, I'll play around with that a little bit. Like I said, it's not supposed to be a UV driven effect. That was just a simple way to get a transition. So I'm not too worried about it. But this is going to go into the layered materials example at the end of the day in the Bevy examples repo, because I think it's pretty cool. It's a little bit complicated to put into the repo, so I might have to make like an advanced section or something like that, so people don't look at it and go, oh yeah, I'm gonna go fork the standard material or whatever. But other than that, it's pretty good. Let's drop the mega scale. Get rid of the UV transform for the moment. Cool. All right, I'm happy with this for the day. It's been almost a 5-hour stream. Wow. All right. Thanks everyone for hanging out. I want to work with shaders, forks Bevy. Yeah, but that's like every Bevy app developer is just an engine developer in waiting. Your guess is the blend should be where the UVX is near 5 unscaled but 5 scaled. That's something like that sounds right. Yeah. Those are just the edges. The 0.05 and 0.075, those are just the edges of the thing. But you're right, I didn't actually set those correctly. That makes sense. I assume you're streaming tomorrow, Sean. I'll try to catch you. But thanks, everyone. I'll probably be around again Monday for stream. Have a great rest of your day.